Hello students, how are you? Hope you all are doing good. In my previous video, I had explained about triangles, the entire concepts which are prescribed in your syllabus for class 9. That is for class 9, I have explained in my previous video. All the content, whatever content you have to learn, you are supposed to learn this year had been explained in my previous video. Now, we will start solving the exercise problems based on those concepts. Okay, so this is the first exercise, that is 10.1. From that, the first question I had already solved in my previous video. If you want to watch the introduction of triangles chapter, you want to know the concepts once again, you want to just revise it or have a recap of it, you can see the description box. I have given the link there. Now we will move on to the second question. The question says, ABCD is a quadrilateral in which AD is equal to BC. ABCD is a quadrilateral in which side AD is equal to side BC. Okay, and they also say angle DAB, that is this angle, is equal to angle CBA. Fine. Now we have to prove that the triangle ABD, that is this triangle ABD, triangle ABD, that is the one which is like this, is congruent to triangle BAC, that is the one which is like this, BAC. We have to prove that these two triangles are congruent to each other, that is ABD and BAC. So I have just for more clarity, I have drawn it separately. Fine. And the given information is side AD is equal to side BC, side AD is equal to side BC, also angle DAB is equal to angle CBA. This is the given information. Now, based on the criteria which you have learned, just recall the criteria that you had learned earlier. How many criteria did you learn? The criteria which you have learned are 5. ASA, SAS, SSS, RHS and AAS. Okay. All these are the 5 criteria that you have learned. Using one of these, we are going to prove that these two triangles are congruent to each other. Okay. Now, considering given to proof, all that you will have to write. In the case of geometry, it is compulsory that in your solution you have to write given to proof. Due to lack of space, I am not writing that. Fine. I will directly go on to the proof. Proof is consider triangle ABD and triangle BAC. Consider these two triangles. Okay. It is already given that side AD of triangle ABD is equal to side BC of triangle BAC. This is given information. So we will write given. And it is mandatory that you write the reason always. When you write a statement or an expression like this, you have to write the reason in your proof. Okay. Then also it is given angle ABD from triangle ABD is equal to angle BAC from triangle BAC. This is also given. This information is also given. So we have taken one side and one angle into consideration as of now. Right? Now, when you see these two triangles ABD and BAC, both these are having the same side, common side. This side is common for triangle ABD and also this side is there for triangle BAC. This side is for this triangle also and this triangle also, AB and BA. Right? Sorry, these two, AB and PA. They are common sides. Okay. So AB is equal to BA, common side, Now you tell me on what basis or on what criteria that we have told or we have proved that the triangle ABD is congruent to triangle BAC. We had considered one angle and two sides, right? Side, angle, side. This angle is included between the sides which we took into consideration. If you can notice, two sides we have taken and one included angle. That is, the angle is in between those two sides. Okay. So, the congruence rule that we have taken is SAS congruence rule. SAS congruence rule. Now, I have proved the first part. That is proving the triangle ABD is congruent to triangle BAC. I have proved the first part. Now, I have to say that the side BD is equal to AC. That is, this side BD is equal to AC. If you see here, it is BD is equal to AC. I have to prove. I can prove. I had told you in my previous video that we have six informations with which we prove that the two triangles are congruent. Now, according to the congruence rules, we are using only three information to prove that, three set of information to prove that the two triangles are congruent. So, when the two triangles are congruent, obviously the remaining sides and angles, corresponding sides and angles will be equal. Hope you all remember what are congruent triangles. All the corresponding sides of both the triangles will be equal and all the corresponding angles from both the triangles will be equal. Now that we have proved that these two triangles are congruent to each other, I can say that side BD is equal to side AC by CPCT. What is this CPCT? CPCT is corresponding parts of congruent triangles. CPCT stands for corresponding parts of congruent triangles. So I have proved that these two triangles are congruent. So obviously the other corresponding parts will be equal. That is how BD is equal to AC. Okay. Now the same way, the third one, that is angle ABD, that is angle ABD, that is this angle, should be equal to angle BAC, that is this one. Right? Now if I mark it in the actual figure, angle ABD, that is this angle, is equal to angle BAC. I have to prove that these two angles are equal. Again, coming back to the same point, they are the corresponding parts of congruent triangles. They are the corresponding parts of the congruent triangles. So I can directly say that angle ABD is equal to angle BAC, and for this also the reason is CPCT, corresponding parts of congruent triangles. Hope you all understood this. Moving on to the third question. AD and BC are equal perpendiculars to a line segment AB. Okay. AD and BC are equal perpendiculars to AB. Equal in the sense the lengths are equal. Okay. So it is given that AD and BC are equal. AD is perpendicular to AB. The line AD is perpendicular to AB. Also BC is perpendicular to AB. They are equal perpendiculars. Fine. And we have to prove that CD bisects AB. That is, the line CD divides AB into two equal parts. That is, I have to prove that BO is equal to OA. That is, BO is equal to OA. That is, I have to prove that O is the midpoint of AB. That is what we have to prove. Okay. Moving on to the proof. Now we have, you can see two triangles here. This one triangle OAD and OBC. Okay. So consider those two triangles, triangle OAD and triangle OBC. Fine. Now considering these two triangles, now I have to try and prove that these two triangles are congruent to each other. In that case, I can easily prove that O is the midpoint of AB, or I can say side BO from triangle OBC is equal to side OA from triangle OAD. Okay, fine. Now I know that angle OAD is equal to triangle OBC is equal to 90 degree because it is given. It is given that AD and BC are equal perpendiculars to a line segment AB. AD and BC are equal perpendiculars to, perpendicular in the sense the angle between them will be 90 degree. That is how I wrote here 90 degree. Okay. Then it is also given that BC is equal to AD. This is also given because they are equal perpendiculars to AB. Right. So it is given that BC is equal to AD. Now I need one more information to prove that these two triangles are congruent to each other. One angle and one side I have taken into consideration. Now I cannot take these two because I don't know whether O is the midpoint of CD, right? Sides. I cannot take angle C and D. Can I take? Is it possible? Can I take? I can take because BC and AD are perpendiculars to the same line, so I can consider them to be parallel, right? Or you can even write angle BOC is equal to angle AOD, vertically opposite angles. Vertically opposite angles. That is BOC and AOD are vertically opposite angles. So now the triangle OAD is congruent to triangle OBC by which congruence rule? Angle, angle, side. Two angles and one side I have taken. So Aas Congruence Rule. Since both the triangles are congruent, three pairs of informations we have taken, the remaining corresponding parts will be equal. So I can say that OB is equal to OA or BO is equal to OA. Now this has become equal to this by CPCT, that is corresponding parts of congruent triangles. Now since those two sides BO is equal to OA, we can say that CD bisects CD bisects AB. Okay. Now what is the meaning of bisecting? Dividing it into two equal parts, which we have proved. It has divided. CD has divided OB and OA. AB has OB and OA. Two equal parts. So we can say that CD bisects AB. Moving on to the fourth question. In the fourth question they say that, or it is given that two parallel lines L and M, okay, are intersected by two other parallel lines P and Q. Hope you all remember what are parallel lines. Parallel lines are lines which are at equal distance from each other. That is, they never touch each other. Right? Okay. Now, there are two lines L and M. They are parallel to each other. Fine. And they are intersected by two other parallel lines P and Q. So, P is parallel to Q and L is parallel to M. We have to prove that the triangle ABC, that is this triangle, is congruent to triangle CDA, that is one more triangle. You can see two triangles in the figure, given figure. Okay. They have only joined the points A and C. Okay. Now, moving on to the proof. Consider triangle ABC and triangle CDA. Okay. Now I can say that this angle is equal to this one. That is, angle BAC is equal to angle ACD. How can I say that these two angles are equal to each other? Because the line P is parallel to line Q and AC is the transversal. Okay, so they are alternate angles. Okay, they are alternate angles. Alternate angles are equal if two lines are parallel to each other. That you have learned in lines and angles chapter, right? Fine. Now I can also say that angle DAC is equal to angle ACB. Angle ACB. Angle DAC is equal to angle ACB. Why? Here again they are alternate angles. How they became alternate angles? Alternate angles are equal when two lines are parallel, right? Here which two lines are parallel? Line L is parallel to line M. So I have to mention that also, how alternate angles are became equal. Line L is parallel to line M. So the alternate angles are equal. Now if you see these two triangles, you can make out that the line AC is common for triangle ABC and ACD. Right? The line AC or the side AC is common for triangle ABC and triangle CDA. So I can write AC is equal to CA because they are common for both the triangles. Now this implies that triangle ABC is congruent to triangle CDA. Now which congruence rule has to be applied here? Here angle, side, angle. That is how I have taken into consideration, right? Angle, side, angle, angle, side, angle. So by ASA, included side, ASA congruence rule, both the triangles are congruent to each other, and that is what we are asked to prove. Hope it is clear to everyone. If you have any doubts, you can mention in the comment section. Definitely I will respond. Thank you.